All right, we're back. We're still on page 186. We're still doing moving a point back and forth or just from one place to another place, however you want to think about it right now. And it's a really important concept, and that's why we're here for a really long time. So the next thing we want to do is we want to look at this. So same point, 3, 8, 9, -4, constant velocity. That's a requirement for us because we don't know the calculus that would deal with variable velocities. So we just have to deal with that. Find parametric equations to model the situation described below. Don't forget to specify the domain. That's really important, especially when you're starting one place and ending another place. It's kind of different if it just like passes through the point. Then it doesn't really matter. But if you have to stop there, then you want to really think about it. So we know that just from these points, delta x is going to be 6. Delta y is going to be -12. Like we know that, right? That's just what you get. If I want the trip to take 10 seconds and I need to span 6 units for x and I'm going at a constant velocity, then each second I need to go the same amount of x, basically. So what I want to do is I really want to use delta x, which is 6, divided by 10. So I'm going to say that my equations, so to guarantee that it takes 10 seconds, so I'm going to start at 3, 8. I'm going to take my delta x, which is 6, and divide it by 10. And then I'll multiply that by t. And then when t gets to be 10, it'll just be 3 plus 6, which is 9, which is what I want. Now I'll do the same thing for y. So I'm thinking like of unit change, right? So I want to go delta x over 10 is like my x velocity. And the delta y over 10 is my y velocity, or the component of velocity, right? So it's 6 units in 10 seconds. So 6/10 units per second times seconds will give me units, and that's what I want. So we're just doing kind of like some very basic sort of physics, I guess, but like you can deal with these just by thinking, which I think is good. So that will definitely work. Well, what if I wanted it to take 20 seconds? So really similar. You have to start at 3, 8. So delta x is 6. So I need to cover 6 units in 20 seconds at a constant rate. So I need to cover 6/20ths every second, and I'll multiply by seconds. And then here I have to cover 12 in 20, and it'll be in seconds. So this, I keep making that t first, which is annoying to me. There we go. So this is like the generalization of how you do it. So you have your delta x, you're going to divide by the amount of time you want it to take. That gives you like units per second. And then you multiply by seconds, and it works out perfectly, like dimensional analysis type thing. So here, so once you get the hang of this, you can knock these out really quickly. So this will be plus 6 over 60. Now you might notice, and you might think I'm just doing this out of laziness. Not the case. I'm not simplifying any of these, right? So I didn't simplify 6 over 10, -12 over 10. I'm not simplifying anything because if they're unsimplified, it's really easy to see that delta x is 6, and it's going to take 10 seconds. As long as both of these work out, you can kind of like see what's happening. Here, delta x is 6, it's going to take 20. Delta y is -12, it's going to take 20. So you're going to decrease by 12, but it's going to take you 60. You're going to increase by 6, but it's going to take you 60 to do it. It's really nice if you don't simplify. And then here we can kind of generalize and say, well, that was weird. We can say x is going to be 3 plus 6 over n times t. Y is going to be 8 minus 12 over n times t. And then your time interval, though, is going to be 0 to n. So that's kind of interesting, because that's like extra things. So here in a box, it's been a while since we had a box, is like a generalization of what we can do. So if we're going to move, so it's important, like you're moving from a point, it's like vectors, right? So where you start and where you stop really matters. So your delta x, your delta y. So we're moving from here to here, which is what makes our delta x be x2 minus x1, y2 minus y1. Like you have to do that. And then if it's going to take you t max seconds, then what you're going to end up doing is this, where you start plus delta x over t max times t, where you start plus delta y over t max times t. And then it'll just take you from 0 to t max. That's how we can do it. So this is a generalization in case you were struggling a little bit or you just wanted it like written down somewhere. I think thinking about it is the best way to do it. Play around on GeoGebra. Once you get this down, you're not going to forget it. And that's really good because you're going to keep using it like forever. So I'm going to stop this video here. I'll come back in the next one and we will keep going. So I'll see you there.